Jeremiah Horrocks, a very curious astronomer, and Chris missed out the very when he originally put the talk up, but you'll see that that's a direct quote, so I wanted to get it right. So, indeed, one of the great days of my life, one of the great days of my daytime observing life, I think you'd say, along with the solar eclipses, was that wonderful day, June the 8th, 2004, and that beautiful sight of Venus on the face of the sun. Venus is that that jet black drop, it's a circular disk on the face of the sun, just arrived on the face of the sun there, that occupied us for quite a lot of the day during June the 8th, 2004. As I say, my absolute favourite observing sight is the total eclipse of the sun, which is so completely overwhelming, dramatic, and short. I was in Western Australia back earlier in the year for an eclipse that lasted 53 seconds. It was certainly worth it, but it was dramatic and it was over very quickly. Whereas this was an event that went on for several hours, so not as overwhelmingly exciting, but still of great, profound significance. I watched it from, well, first of all, from my back garden in Rugby, and then I got in my car and I drove along the A14 to Cambridge for reasons that will become pretty apparent soon. So I watched it all day. I got actually stuck in a traffic jam on the A14 at one point, as you're often want to do these days. There's an event going up in the sky, and there I am stuck in my car for half an hour or so. Quite frustrating, but I got there in the end to watch the rest of the transit. So what's the significance about it? Well, on the morning of June the 8th, 2004, nobody alive had seen a transit of Venus. They occur so infrequently that it was over a century since the previous one. There were people who had lived for over a century. The Queen Mother, Bob Hope, who had never even had chance to see a transit of Venus. I don't know whether or not they would have wanted to, but the point is they lived to the age of 100 and they never even got the opportunity to do so. Because in the present epochs, transit occur usually in pairs, 8 years apart. So telling you about the recent ones, June the 8th, 2004, and then 8 years later, barring a day or two, June the 5th to the 6th, 2012. It wasn't like we didn't know which day it was. It would cross the international date line. That wasn't as well visible from Britain, although I did see it from a campsite near Banbury, where I was camping with my friends from Rugby Astronomical Society. And before that, December the 9th, 1874, and December the 6th, 1882. So none at all during the 20th century, 1882. And then that huge gap of 122 years through to 2004. And before that, another pair in June the 6th, 1761, June the 3rd, 1769, and before that, another pair, 1631, December, 1639, December the 4th, except that they had the previous style calendar, 1752, when they changed the calendar, so they thought it was November the 24th, but they were wrong. It was December the 7th and December the 4th. And you can see there is that curious periodicity there, pairs 8 years apart, one pair in June, 120 years after another pair in December, which was 105 years or thereabouts after another pair in June, which is 124 years after another pair in December. So clearly there's something going on there, and I'll try and give you some idea of what's actually happening. Sometimes you don't get a pair. If you go back a few more hundred years, there's only one pair for, I think, the December transits, but no, don't quote me on that, but it's a pretty good rule of thumb. And you can see also that they're not quite 8 years apart. Again, I will try and explain that to you. The great thing about it, the person we're going to talk about tonight, is that the transit of December the 4th, 1639, was first transit to be observed. And the man who observed it is the guy I'm going to tell you about tonight, and his name was Jeremiah Horrocks. So let me give a little context to this talk, first of all, by justifying the statement I made that the first transit observed was in 1639. Is it possible that people might have seen transits of Venus before then? And the answer is yes, it is possible. And from time to time, people do make claims that people had seen it in ancient times. For example, there's an Assyrian tablet in the British Museum that says something along the lines of the planet Venus ... It passed across ... The sun ... The face of the sun. I'm not convinced by that. There's an awful lot of dots there, and I think you're reading into it our present day knowledge. So and the Assyrians, I know, are very good, were very good astronomers for their time, so I can't rule out the fact that they may have seen something, but I'm, as I say, not absolutely convinced by that. Another one, for example, from the Norton History of Cosmology and Astronomy. There used to be a picture near a sacred underworld lake at Chichen Itza, that wonderful Mayan city in the Yucatan in Mexico. This showed a square sun, not a good start, rising over the horizon, and it carried a date equivalent to 15th of December 1145. Modern calculations show a rare transit of Venus was indeed seen that day. Well, the square sun is not good, but it's quite impressive that they think that transit of Venus, they may have they carried the date was equivalent to the day when there was a transit of Venus, and that would have been even more impressive if there had actually been a transit on that day. In fact, there wasn't. So it's all too easy to make claims for too strongly that some of the ancient cultures might have seen transit of Venus. But I could be persuaded. I think if there's any culture around there who knew about possibly knew about the transit of Venus, it would be the Mayans, for whom Venus was a central part of their cosmology. And I know there are claims that Montezuma or his astronomer priest might have seen the transit of 1518, which was at sunset from Mexico. So that's the sun would be diminished, so it would be possible to see detail on it with the naked eye. We had a BA historical meeting up in Stirling a few years ago. We had a young woman who was a PhD student from Mexico at Edinburgh University, and she talked to us about Mayan astronomy, and she was quite convinced that the Mayans had seen the transit of Venus before anybody else did. So and she knows more about astronomy than I do. So I have to say it's possible, but I'm not convinced. To see a transit of Venus, you need to be able to observe the sun. Fairly obviously, you need to be able to see but the sun is, as we know, is so blindingly bright that even if a transit was going on, you wouldn't be able to see it if the clouds were clear and the sun was high in the sky. It would just be too overwhelmingly bright. You would do yourself a mischief trying to see it with a naked eye. You blind yourself instantly if you tried to watch it through any kind of magnification. So you'd have to rely on some clouds being in the way, and if this is in pre-telescopic times, or a sunset when the light of the sun is much diminished, or if you knew about it, a pinhole which would allow you to project the sun. You need to be able to recognize Venus. It sounds fairly obvious, but when the first transit of Venus was seen, Venus was a lot smaller than people were expecting. So you'd have to say that spot on the sun is not a sunspot, which again were not that well known to people, but a perfectly round spot, the size of Venus. And of course, it would help if you knew that the transit was taking place, and that's rather more difficult. Predicting a transit of Venus, well, that requires an understanding of the motions of the planets based on comprehensive and accurate measurements. Now, the Mayans certainly took lots and lots of measurements. They knew a lot about the orbit of Venus, but even they, again, I'm not convinced that they understood they understood that the Venus, I think, was approaching the sun. They'd understand the inferior conjunction as it approached the sun, but did they know enough to say that sometimes it'd go beneath the sun, sometimes above it, and every once in a while, every few hundred years, it would actually cross the sun? Did they know that? Maybe, probably not. I think we had to wait until the new astronomy, which was a combination of various things. The sort of heliocentric theory of Nicholas Copernicus, that the sun is at the center of the solar system, and this simplifies the motions of all the planets. You get rid of all the epicycles and the peculiar motions of the planets, which you can retrograde and so on. We had Tycho, the greatest of the pre-telescopic astronomers, who was the most accurate of observational astronomy before the invention of the telescope. We had Galileo Galilei, who didn't invent the telescope, but was the first person to use it for astronomical purposes. And we had Johannes Kepler, one of the Blackadder lookalike there, one of my heroes, mathematician, astronomer, extraordinarily creative mathematician. I don't think people give him the credit for that. And he was the one who managed to take Tycho's observations and turn them into a theory of how planets moved around the sun. He came up with 3 laws. I've never read his book, and apparently it's a sort of stream of consciousness explaining how he dealt with the data and tried to find patterns in it, and failed. Various theories he tried out were wrong, but eventually he stumbles maybe not the right word. He had a flash of intuition that the orbits of the planets around the sun were not circular, they were not epicyclic, they were elliptical, a squashed circle, and not only a squashed circle, but a squashed circle with the sun at one focus of the orbit. The second one explained the speed of motions around that elliptical orbit. The line joining the sun to a planet sweeping out equal areas in equal times. So it goes at its nearest point to the sun, it's moving at its fastest. So when it's furthest from the sun, it's moving at its slowest. And then 10 years later, the Kepler's third law, which it tells for all the planets moving around the sun, relates how fast they move, what their orbital period is, to how far they are from the sun. So the orbital period, in whatever units you want to choose, divided by the semi-axis, which is half the distance to the sun, cubed, square of the first divided by the cube of the second, is constant. And what that means is that Mercury goes around the sun very quickly, not just because it's got the shortest distance to go, it is actually moving a lot faster than all the others. And then Venus are rather slower, Earth slower still, Mars slower still, all the way out to Neptune and Pluto, which are moving very, very slowly. And we know from observations that Venus goes around the sun in 224 3/4 days, and Earth, as we very well know, goes around the sun in 365 1/4 days. And from that, or from observations really of how far away from the sun Venus gets, you can do this calculation. Venus must be 72%. 0.723 astronomical units, an astronomical unit being 1 for the Earth, the distance from the Earth to the sun. So Venus is about 70% of the way from the Earth to the sun. But the other thing about that is that from its orbital period, if you do that 224 days and 365 days, is that Venus is moving around faster, so it catches up the Earth. And every 1.6 years, it is very close to 1.6, Venus catches up with the Earth, and you get a conjunction. Venus undertakes Earth on the inside and passes between us and the sun. So why don't we get a transit at every conjunction? And the answer to that is because the Venus's orbit is tilted with respect to the Earth's orbit around the sun. It's not by very much. The orbits between the orbits of the Venus and the orbits of Earth around the sun are tilted at an angle of just 3 degrees. But what that means is that usually when Venus comes between the Earth and the sun, it's either underneath or over the top of the sun. The only time when you can get a transit of Venus is when Earth is moving through the plane of Venus's orbit, which it does once in June and once in December, and that's why you get transits only in June and only in December, and that changes over tens of thousands of years as the orbits precess. But for periods of a millennium or so, that's a good rule of thumb, that you only get transits in June because Earth is going through the plane of the orbit of Venus. Usually Venus is somewhere else on its orbit, but every 300 years or so, it happens to be in the right place to get a conjunction. And then over the other side at that E2 point, that's the time in December when Earth crosses through the orbit. And so every 300 years or so, you get a pair of them in December. And Kepler, Johannes Kepler, that great mathematician come astronomer, he predicted them. His mathematics was good enough that in the Rudolphine tables, for the first time, he was able to accurately predict both transits of Mercury and transits of Venus, so the only 2 planets closer to the sun than us, and therefore the only 2 planets that can actually transit across the sun. He predicted a transit of Mercury on November the 6th, 1631, and a transit of Venus on December the 7th, 1631, 2 within a month of each other. Transits of Mercury, you get about 13 or so a century, so they happen not very often, but fairly frequently. Venus, as we know, know are very infrequent. So he predicted this transit 1631, and it was observed. Jeremiah Horrocks definitely wasn't the first person to see a transit of anything. That honour belongs to the French astronomer Pierre Gassendi. Pierre Gassendi was looking because Kepler's tables told him he should look, and he was observing, and he observed from his observatory in his house. I think there was a cloudy day, and when the clouds parted, there was a small, tiny little dot, much smaller than anybody expected, on the sun. He realised it Mercury, and he had an assistant. And the plan was, if he saw the transit, he'd bang on the floor, and the assistant had come and witness. So he banged on the floor, and apparently it turns out the assistant had gone for lunch. So imagine being in this position where you've seen this remarkable event, you've got no witnesses to back you up, to corroborate your evidence, and if the clouds come out, nobody's going to believe you. Fortunately, the assistant came back from lunch. That must have been quite a conversation. So he predicted, successfully observed, that transit of Mercury November the 6th, 1631, and that transit of Venus in December 7th. Gassendi tried to see it, but nobody actually observed it, and I think that's because it just wasn't visible from France. From memory, it just clipped bits, the western bits of Europe, so absolutely nobody saw it. So I once wrote an article about this in which I said Gassendi tried to observe the transit of Venus, having seen the transit of Mercury, but didn't see anything, to his and to Kepler's frustration. And I sent this to a friend of mine. I quite often send articles, just proofread, make sure I haven't done something stupid. And he emailed back to me to say, in December 1631, Kepler was not frustrated, he was dead. He'd already died a few years before. And so I emailed back saying, well, how do you know he wasn't frustrated? But I think looking at it, imagine, he wrote these tables in 1627. He made these two extraordinary predictions. And unfortunately, he didn't last more than a couple more years, I think. And imagine knowing that you've made these predictions and not being able to hang on long enough to see whether or not they were justified. Very, very, very frustrating. So that's the context. There you go, November 16, 1630, within a year of that transit of Mercury that was successfully observed by Pierre Gassendi. So that sets up the context of my talk. The mathematics and the astronomy was good enough at the beginning of this Renaissance period to predict transits of Venus, transits of Mercury. The transit of Mercury had already been observed, not a transit of Venus. So into this context comes, this is Pierre Gassendi. I love that they don't write like this in scientific papers anymore. He wrote, "I've been more fortunate than those hunters after Mercury who sought the cunning god in the sun. I found him out and saw him where no one else had hitherto seen him." They don't write papers like that anymore. And this is the 2003 transit of Mercury, which was visible from Australia. And you see Mercury at the top there. It really is tiny. The gaps are not because Mercury flickered out. It's because there was it's a cumulative photo, and there was cloud around at the time. And what you also see are the sunspots, which in this case tend to be rather bigger than Mercury. And if you're wondering why they're kind of linear sunspots, it's because the sun was rotating as they added all those pictures together. So it was a smaller sunspot, which as Mercury is making its way across the disk, the sunspot is rotating with the disk. So there we go. Gassendi saw it. I've seen 2 or 3 transits of Mercury. The last time there was one from Britain, my local society set up on the parade at Leamington Spa with a telescope projecting Mercury, and anybody who wanted to come along could come take a look at it. And people were genuinely interested. People come along, what you're looking at, and we'd point out that little dot on the sun is Mercury, planet Mercury. Oh yeah, interesting. Didn't stay long, but I think we did a good job. So, sorry, Jeremiah Horrocks, finally get round to the subject of my talk. We don't know that much about his early life. It's likely, we've got no birth certificate, but it's likely he was born in Toxteth, which these days is a suburb of Liverpool, and in those days was a village some way outside the port. But it's possible he was in 1619 rather than 1618. It's also possible that he was born in Bolton, in the Bolton suburb of Dean, rather than in Toxteth. And his mother was Mary Aspinwall of Toxteth, and his father was James Horrocks, a watchmaker, or possibly William Horrocks, a farmer. It's not like Mary didn't know. If he was born in Toxteth, his father was likely James Horrocks. If he was born in Dean, then it was likely William Horrocks who lived in Dean. So I'm going to say pretty well certainly that he was born in Toxteth to Mary Aspinwall and James Horrocks. He was probably educated by Richard Mather, who ran a school in Toxteth. In fact, you can see the details are fairly slim, as they are for many people from the 17th century. But the first location where we can place him for absolute certain was here, Emmanuel College in Cambridge, where he came, like many bright boys of the era, to come and study. Alan Chapman is really good on this sort of thing. He said the really wealthy individuals had their own private tutors. They had no need for universities, but the bright kids from the sort of middle classes, from the trades, they were the people who came along to the university of the day, in particular to Cambridge and to Oxford, or possibly the Scottish universities. And so they were rather more egalitarian than you might expect, that they were for bright kids from, or bright boys. They weren't egalitarian in that respect, but bright boys from all over the country. And this is Emmanuel, a very beautiful college. This is not a view that Jeremiah would have recognised. This is the chapel and the gallery, which was built by Sir Christopher Wren in the 1670s, and Jeremiah was there in the 1630s. But it is one that is very recognisable to me, because I was an undergraduate at Emmanuel from 1982 to 1985. I matriculated, oh gosh, I do the calculation, 385 years and 6 months after Jeremiah Horrocks, so we never met. I did mathematics as it was my undergraduate degree at Cambridge University. Emmanuel is a very beautiful college. If you go underneath the gallery to the right, you get into some of the nicest college grounds of all the Cambridge colleges. Of course, I'm biased. It's a rather more austere chapel than King's, say, or Trinity, or most of the other colleges, because Emmanuel, as we'll see, was founded as a Puritan college back in 1584. So we know he was there, and the reason we know he was there was because he signed the register. This is the Emmanuel College admissions register for 1632. That would be 349 years, 6 months before me. Yep. Jeremiah Horrocks, you see, I've annotated it there. Lancashire, May 18th, 2 shillings and 6pence. Those were his tuition fees. They've gone up rather more subsequently. And you can see, if you look there, some of them are 10 shillings and some of them are 2 shillings and 6pence. Let me explain that shortly. Let me point out a couple above him is a chap called Ralph Cudworth, who was quite a leading, became one of the leading theologians of the period. It's probably not Jeremiah's handwriting. You can see they're all quite similar, so it's probably written in the book by somebody else on his behalf. They also signed the university's matriculation register, and there I think it is his own handwriting. And there also is next to a chap called John Worthington, who I will talk about later. So it's at Jeremiah Horrocks, Lancashire, May the 18th, 2 shillings and 6pence. And Mr. William Bennett wrote a register of college admissions century and a half later, a very useful reference book of all the people who had matriculated to Emmanuel at that point, since its foundation in 1584. 1632, May the 18th, Horrocks with an X, Jeremiah S. Lancashire at Toxteth, was a very curious astronomer. That's where I get the very curious bit from. And the S means that Jeremiah Horrocks was a sizar. That's somebody who had reduced fees in return for which he did tasks around college. Like, if he was lucky, he waited on the tables, and if he wasn't quite so lucky, he emptied the chamber pots. And this was an educational route that many not quite so wealthy kids took. Jeremiah Horrocks was a sizar. Isaac Newton was a sizar 50 years or so later, when he was an undergraduate at Trinity College. Another young student from the 17th century at Emmanuel. My father had a small estate in Nottinghamshire. I was the third of 5 sons. He sent me to Emmanuel College, only one M, never mind, in Cambridge at 14 years old, where I resided 3 years and applied myself close to my studies. Didn't we all? Any guesses as to who that might be? You might be surprised. You may have already read this, because that is one of the opening paragraphs of Gulliver's Travels. Lemuel Gulliver, it's written as a sort of autobiographical account of his wonderful thing. So Jonathan Swift, I think, is trying to establish him as an ordinary guy. Went to university, went to Emmanuel College, not the posh colleges like Trinity and so on, just one of the ordinary bog standard colleges in Cambridge. At 14 years old, that's it might sound a bit young, but actually that's the pretty much the age that which Jeremiah Horrocks went there. They went there younger, and the curriculum was closer to what we now say were A levels than the undergraduate. So if you do there's a sort of timescales and things in Gulliver's Travels, and if you add it all up, Lemuel Gulliver was rather more likely, if he actually existed, to have met Isaac Newton than Jeremiah Horrocks, because it's set. Gulliver's Travels is set in the late 1600s, so he would have been an undergraduate at Emmanuel around in the 1670s, something like that. But he wasn't by any means the only person from the early years of Emmanuel. That's quite a remarkable place. It's founded in 1584 by Walter Mildmay to be a Puritan college. There's something of a backlash against the sort of religious turmoil of the times, and they decided to found a college that had a sort of very back to basics approach to Christianity. In particular, none of that Catholic finery that they were getting, and indeed none of the sort of high Anglicanism that was around at the time. It was very much very austere type of Christianity. However, many of the scholars from the King James's Bible were Emmanuel men. So there was certainly scholarship and beauty, and then a lot of people who were even non-religious would regard the King James's Bible as a work of beauty. So what also happened was that as we got into the time of Jeremiah Horrocks, is that there was a lot of backlash against the Puritans, a lot of persecutions. In particular, Archbishop Laud took to burning them at the stake. So a lot of the people who just simply wanted to pursue their religious beliefs without bothering anybody, decided the best way to do that was to emigrate to the new colonies of New England. So a lot of Emmanuel students graduated to New England. In particular, a couple of them. John Harvard matriculated in 1627, graduated in 1631, so he would have just missed meeting Jeremiah Horrocks, although he came back. That's quite a common thing, to take his MA in 1636. What actually happened was, then like now, the MA is something of an honorary degree. These days you get it, or at least they did in my day, by staying out of jail for a year, and then they give you an MA for free. I think there was rather more refinery and tips had to be taken, had to be given, and so on to get your MA in those days. But John Harvard took his MA. He was a wealthy man. He came from not far away from where I am in Warwickshire. He came from Stratford-on-Avon. He emigrated to America, and pretty much immediately donated a lot of money to found the first university in America, Harvard University. And indeed, if you go to Boston, you'll see this statue of John Harvard in the main square of Harvard University. So Harvard is the first American university. It was founded by an Emmanuel man, John Harvard, and we maintain at Emmanuel very close contacts with Harvard University. Slightly less better known is a chap called William Blackstone, born in 1595, took his MA in 1621, and sailed for America rather before. So there's no chance that William Blackstone would have met Jeremiah Horrocks. And the reason I'm interested in him, he was the first settler in Rhode Island, and like William Blackstone, I have relatives in Rhode Island. 120 or so years ago, some of my great grandmother emigrated to Rhode Island with several of her kids to get away from the downturn in the cotton industry in Lancashire, where I grew up. So most of it, I have a lot of third cousins and fourth cousins in Rhode Island and Massachusetts. William Blackstone was the first settler in Rhode Island. 1635. Amongst the people who went with him was somebody who actually wrote a letter to Jeremiah Horrocks from Rhode Island. And there's another of my talks where I discuss Jeremiah Horrocks' connections to New England and to the state of Rhode Island. So we've only got one picture of William Blackstone, and I'm fairly sure that it's not an accurate representation And if you want to ask later, there's a fascinating story behind the William Blackstone as Mr. Potato Head there, that with some interesting lessons to be learned from it. So Jeremiah Horrocks came from this very Puritan background in a group of people who were very scholarly, but also inclined to go across the Atlantic to pursue their beliefs. The study at the time consisted of Latin and Greek and Hebrew and literature and divinity, not very much astronomy. If there was, there'd be some geometry into mathematics and classical, that's to say ancient Greek astronomy. But Jeremiah Horrocks was somebody who did things his own way, and he began private studies with a copy of Philip Landberg's astronomical tables. Philip Landberg was a Belgian astronomer, okay, but not great, not quite in the sort of Kepler league. More pertinently, he built up a network of friends, and Ralph Cudworth I've already discussed. John Wallis he knew at Emmanuel. John Wallis was literally the Alan Turing of his day. He was a geometer, very fine mathematician, on whom Isaac Newton's work on calculus was built, and he was also a cryptographer for the parliamentarians during the English Civil War. So literally the Turing of his day. John Worthington, who became I think it was Bishop of Manchester or something like that, something clerical in the Manchester area. And then by correspondence, he got in touch with some of the scientific men of the day, William Crabtree, a draper in Salford, who we'll meet later on, and William Gascoigne, a superb instrument maker from Leeds, the man who invented the filar micrometer. So he didn't particularly like his time at Emmanuel. Unfortunately, it was rather a pity. But his studies led him in good stead, and that network of friends that he built also led him in good stead. When he left after 3 years of education at Cambridge, he probably returned to Toxteth, and we know from his letters that he began making assiduous observations. He was a very good observational astronomer, and he particularly interested in the motions of the planets and the moon. Our fellow countryman Horrocks was the first to propose that the moon revolves around the Earth in an ellipse. Who do you suppose wrote Rose? Well, those are words from Principia Mathematica, Isaac Newton. And Isaac Newton was not somebody who praised people lightly. If you got to Isaac Newton being polite about you, you had to be really good indeed. And it probably helped that by this time Jeremiah Horrocks was already dead. Isaac Newton certainly didn't like praising the people who he worked with and knew, in particular Robert Hooke, who he didn't like at all. But he was quite generous in Principia Mathematica to figure out that Jeremiah Horrocks was one of the first people to propose the moon revolves around the Earth in an ellipse, and he did that essentially by measuring the size of the moon in the course of its orbit. As we know from the supermoon hyperbole, that sometimes the moon is bigger and sometimes it's smaller, and that's because it's closer and sometimes it's further away. And if you take those very careful measurements, you can figure out the movement of the moon. It's a bit more complicated than just an ellipse, like Johannes Kepler said, because the orbit of the moon is not just around the Earth, it's tugged very strongly by the sun as well. So it's an ellipse that precesses. But Jeremiah Horrocks was made one of the big steps up in understanding the movement of the moon. And we have pretty good models these days, but they are complicated. So another quote, somebody else who said he detected the long inequality in the motion of Jupiter and Saturn. And this is actually from the memorial to Jeremiah Horrocks in Westminster Abbey. Says overlooking Isaac Newton's memorial, and it overlooks Isaac Newton's memorial in much the same way that the White Cliffs of Dover overlook France. Yes, they do, but they're a long way away. It's by the western door, the one that people emerged from, that Kate and William emerged from when they got married. I doubt they stopped to admire the monument to Horrocks on their way out, but that big door, it's just by that. And the long inequality of the motion of Jupiter and Saturn. Horrocks is the first person to spot that the orbits don't quite obey the laws that Kepler put out. That sometimes they don't quite obey the second law. Jupiter slows down in the sky when it's close to Saturn, or it speeds up as it's approaching Saturn and slows down as it's moving away from Saturn. And Saturn slows down very slightly, but slows down slightly when it's past Jupiter and speeds up as it's approaching Jupiter. He realized that whatever was making these planets in the sun move around in the orbits that were so very accurately described by Kepler, had some more subtleties to it, and those subtleties seem to be due to interactions between Jupiter and Saturn. Jeremiah Horrocks was the first person to describe that. He didn't know it was gravity. He didn't know that it was the gravitational attraction of Jupiter that was pulling Saturn along or holding it back. But he didn't. They just didn't know enough, and that took the genius of Isaac Newton 50 years later to do it. But if that's familiar to you, it's the same route by which the orbit of Neptune was inferred from similar long inequalities in the motion of Uranus. Uranus didn't quite do what they were expecting to do, and that turned out because there was an undiscovered planet there. So 1639, quite early in 1639, Jeremiah Horrocks moved slightly north, not only about 30 miles or so, probably walked along the coast because the roads were pretty dreadful, but he ended up very close to Preston, on the southwest of Preston, in Bretherton, which is a tiny little hamlet. And legend has it that he lived with the Carr family at Carr House in Bretherton, and this is the house where he actually moved. It's not the Carr family. I'll tell you in a second who it was. Very beautiful old house dating from the area, the Stones family, I think. And there's a carving above the door that tells you all about the house. And you see, it does look imposing, and that's because it is. But actually, there's a lot of depth to it. It only goes one room deep, so it's a wide house, but not a deep house. And in particular, there are no windows on the western side. That's the left-hand side of the house. And the only window in the house that observes west is in the middle, in the master bedroom. And that is of great significance. So the Chorley Civic Society are in no doubt. Jeremiah Horrocks observed the transit of Venus from Carr House, 24th of November 1639. The Victorians were also in no doubt. They were certain that Jeremiah Horrocks was the curate at Much Hoole Church. Much Hoole is a little village, another little village, only about half a mile away from Bretherton, and there's a church there, a very beautiful church, St Michael's Church. And the Victorians, in their biographies of him in the 19th century, said he was the curate at the church. Well, it's possible, but probably not. He was too young. He'd only just emerged from university. Dare say he would probably have become a curate in due course, but there's no records in the ecclesiastical records of this happening. He would almost certainly have been involved in the religious services because he could read. He was literate, so he'd do the readings and so on. But was he the curate? Probably not. Was he tutor to the Stones family? There you go, not the Carr family, the Stones family, who were the resident there. That seems rather more likely. We don't know for certain, but that would make a great deal of sense. They'd employ a bright young man to teach their children, and they'd probably get more astronomy than they were reckoning with. But he'd be the tutor for the kids in the family. So it makes sense, but we don't have definitive evidence to that respect. So there's the context. He's living in this posh house in Bretherton, and not far away is the beautiful church of St Michael's. Now, he's continuing doing his observations, and he knows that Venus is approaching its inferior conjunction. He's doing calculations, and he knows quite an interesting coincidence. I told you about 1.6, which is 8/5 of a year, and so after 8 years, that's 5 lots of 1.6, which is 8 exactly. So 8 Earth years is 13.004 Venus years, and which is almost exact coincidence. It's not an absolute one. You can see that 004. In 8 years, Venus has caught up 5 times, each 1.6, 3.2, 4.8, 6.4, and then 8, 8.9. It catches up for the 5th time. Earth has been around the sun 8 years. Venus has been around the sun 8 plus 5 catch-ups, which is 13. And so, after there is a transit, then 8 years later, Earth has gone around the sun 8 years, so it's back where it was. Venus has gone around the sun almost 13 years, 13 and a smidge. So it's almost exactly back where it was previously. So if there is a transit, there may be another one 8 years later. Kepler knew this, but he thought 1639 would be a near miss. It wasn't going to happen. And the reason for that is it's not exact. That 8 years is and 13.004. It's that 004 that means that maybe it'll happen, but it's not guaranteed to. If you read the Da Vinci Codswallop, that Dan Brown novel, you'll have it stated as fact that 8 Earth years equals 13 Venus years. 8 and 13 are both Fibonacci numbers, and this is indicative of a great of some terrible plot to I forget what the plot is, but it's good. It's all good fun, but there's absolutely no benefit behind it. However, the 8 and the 13.004 is possible, and you can see there's maybe another one 8 years later, and then it becomes increasingly unlikely. And indeed, they just get further and further apart until they meet at the other node 120 odd years later. Jeremiah Horrocks also knew this, but he was determined. He also knew that Kepler's tables weren't accurate. He knew that Philips Landberg's tables from Belgium, he was the Flemish astronomer, he was even less accurate. And what he was determined to do was to find out by his own observations to resolve the differences. So he made lots of observations, and he realized that late October 1639 that there might be a transit on Sunday, November the 24th, 1639, less than a month after he'd made the calculations. As Venus was approaching, he does the calculations and he realized it's possible there might be another transit, probably in the late afternoon, but he's not absolutely certain. He only had time, it's only a month beforehand, and you know what the mail's like these days, it's probably slightly even worse in those days. So he only had time to alert his brother back in Toxteth, Jonas Horrocks, as far as we know, didn't see anything. His friend William Crabtree in Salford, and if you in his letter to William Crabtree, he asks that he might pass on to another fellow Emmanuelian, Samuel Foster, who's the Gresham College Professor of Astronomy down in London. And I do another talk, Jeremiah Horrocks, Samuel Foster, Nathaniel Nye, a detective story where I trace that whether or not Samuel Foster got that letter and whether or not he might have seen the transit of Venus. Well, there's also Nathaniel Nye around, and well, if you ever invite me back to give that lecture, it's a fascinating story. I'm not going to give away the ending of it, but it is extraordinary piece of detective work that I was able to do. Anyway, so he's only had time to warn one or two people this thing is going to happen. So he set up his telescope, legend has it, in the main room above the front door of Carr Hall, Brotherton, looking out the window. And as you can see, it's quite a squeeze. And I know Kevin Kilburn, my friend from Manchester, has tried to do similar sorts of observations, and he says it's close to impossible. Well, it is impossible these days because trees have grown and hedges and so on, so you can't see anything looking to the west, but that might have happened in those days. But even so, it's a very tight squeeze. And Kevin has even written a paper about the non-observation of the transit of Venus from Carr House. He may have observed it from somewhere else, but let's say it's going to be Carr Hall in Brotherton. Because it's such a beautiful location. Horrocks projected the sun onto a sheet of paper marked with a gradated outline of the solar disk 6 inches across. So he's not going to look at it directly. He knows how dangerous that is. He's going to do the safe thing, project the sun onto a sheet of paper, as he must have done many times before. To be on the safe side, it'd be a pity to miss it. So on the safe side, he observed throughout Saturday, November the 23rd, 1639. He wrote down that all he could see on the sun were a few common spots. And that's quite a significant thing because he wants people to be aware. He knew full well what a sunspot was, and he knew he could distinguish between a sunspot and the planet Venus. He also observed from 9 a.m. till 10 a.m. on the Sunday, which is a rather more cloudy day, and then 11 a.m. until after midday. And then, he says, I was called away to greater things, which was certainly not proper to neglect for these subordinate pursuits. He was playing centre forward for Much Hoole United in the Preston Sunday League. No, he wasn't. He was going to St Michael's Church in Much Hoole, where he probably wasn't the curate, but he was a committed Christian, and he was doing the right thing and going to the Sunday service. Imagine that. Yeah, I'm not a religious person myself, but imagine having the faith that says you can't observe this event, which is not going to happen for another 100 or years or so later. You haven't seen it so far. You're fairly sure it's going to happen, and still you go to the Sunday service instead. I bet he was really wishing that the sermon was really short. I bet at the end he was first to say, "Capital sermon, Vicar," sprints out the door, heads off like Usain Bolt for that quarter mile back to Brotherton, back to his telescope to see what's there. He's done his duty, he's done the right thing, and back to his telescope. It was cloudy. It was November in Lancashire. I grew up in Lancashire. It is, if you want to make a time critical observation of something that nobody else knows about, that's not only going to happen once for the next 100 years or so, you really don't want to be in Lancashire in November. So it was cloudy. But then the clouds, as if by divine interposition, were entirely displaced, and I was once more invited to the grateful task of reseating my observations. I then beheld a most agreeable spectacle, the object of my most sanguine wishes, a spot of unusual magnitude and of a perfectly circular shape, not a sunspot, which had already fully entered upon the sun's disk on the left, so that the limbs of Sun and Venus precisely coincided, forming an angle of contact. Not doubting that this really was the shadow of the planet, I immediately applied myself sedulously to observe it. The clouds have parted 40 minutes before sunset in Lancashire. They parted long enough for him to see that the transit he predicted had just started. Immediately applied himself sedulously up to observe it. There you go. That's Chris put up a rather better version of it. This is a portrait of Jeremiah Horrocks doing the observations. It's supposed to be in the Walker Gallery in Liverpool, but they loaned it to the planetarium in Liverpool, and it wasn't in great shape when I saw it in the lead up to the transit. Hopefully they've restored it a little bit. It's also a little bit Heath Robinson. It's unlikely that it's such a long focal length and projecting. It's done for, I'm sure, for dramatic effect, as I suspect is that very Puritan garb, the black and the Pizza Hut hat and so on. So they've got the general idea. The sun was very low in the sky, 40 minutes before sunset. It's projecting as he did. It's projecting onto there, and you saw that little spot on the sun. Rather, another one on this is the stained glass windows in St Michael's in Much Hoole, and you can see on the left is Jeremiah Horrocks observing the sun, that white disk with that beautiful little black spot there, and underneath it Ecce Gratissimum Spectaculum, a most agreeable spectacle. And they're very, very proud. I've been to St Michael's on a number of times. You'll see the visits around about the time of the transit of Venus, but I've also been just an ordinary Sunday morning. My late mother had a friend who had a brother who lived in Much Hoole, and we went along to the Sunday morning service, and they were very friendly. They didn't say, "Oh, God, not another astronomer," but they were, they're very welcoming. It's these days it's shared, I think, both Anglican and Methodist, so it's a welcoming congregation, and they put up a couple more stained glass windows, one for in the 1874 and 1882, 1639. Religious and Science in Fellowship on the top there, and then 1639 Sic Venus Transit, not the transit van, 2004, to commemorate that transit of Venus in 2004. They put up a new stained glass window to commemorate it. Very good. So William Crabtree over in Manchester, he watched out for it too, and if anything, the weather in Manchester was even worse than the weather in Preston. But just before sunset, just a few minutes before, most agreeable spectacle. The clouds parted for just a few minutes. There was the projection again, probably not quite like that, but the general idea is right. The sun was projected, and William Crabtree saw that transit of Venus. Jeremiah Horrocks sedulously observed and made 3 accurate drawings of the positions of Venus, I think at 3:15, 3:30 and 3:40. William Crabtree just stared gobsmacked at it. Like a girl, says Jeremiah Horrocks in his account of it. I'm not making any judgments on this, but you can see there is in Manchester. If you go to Manchester Town Hall, it's certainly worth doing. There's a series of portraits of some of the most spectacular events from the history of Manchester. It's pre-Sir Alex Ferguson, so there's no Beckham free kicks or Cantona or whatever. But it's the arrival of the Flemish weavers and the discovery of marsh gas by John Dalton, and then William Crabtree observing the transit of Venus. And again, Alan Chapman, who's a fellow Lancastrian like me and Jeremiah, says there's William Crabtree with his pre-Raphaelite wife. William Crabtree was like Jeremiah Horrocks, was in his early 20s, but you can have somebody in their early 20s observing a transit of Venus, although apparently they can be married to somebody in their early 20s. So artistic license there, but I like the fact that they've captured the essence, that wonderful, just a few minutes or so when the heavens opened, the clouds parted, and there was Venus on the face of the sun. William Crabtree was therefore able to corroborate Jeremiah Horrocks' observations. If there's a Steve Coogan movie, The Parole Officer, which finished not very good, not very good movie, but it finishes with a chase around Manchester Town Hall. So William Crabtree crops up in the background every so often. Pretty much nothing else to recommend it as a movie. Okay, so Jeremiah Horrocks then spent the next year writing up his account of what he saw on that amazing day. Venus in Sole Visa, Venus seen on the sun. He spent all of 1640 pretty much writing it up because he wanted to milk as much as he could from this. He figured out a number of things. Venus did not shine by its own light. It was not a bright disk as it crossed the sun. It was a dark disk because it was illuminated by the sun, and we were seeing the dark side of Venus. So good astrophysics. He's figuring out how planets work. He probably expected it, but he's confirming it. Venus was much smaller than expected. They'd already seen Mercury, which is absolutely tiny, much smaller even than Venus. But you could say that was one observation by Gassendi, so maybe something had got mistranslated. But they were expecting Venus to be about a third the size of the sun, the apparent size. And as we can see, it is not. It's 30th or something like that. He made some guesses, some quite interesting guesses. He calculated that the astronomical unit, was 60 million miles, the distance from the Earth to the Sun, much larger than previously thought. And how he came by this was that he had to assume that he knew what the size of Venus was. And what he did was assume that the sizes of the planets got bigger linearly as you got out from the Sun. So Mercury was a third the size of Earth, Venus 2/3, Earth bigger still, Mars bigger still, Jupiter bigger still, Saturn bigger still. Now, that's just a working assumption. It's certainly not absolutely true, of course. And even in those days, you'd realize that Mars didn't really fit with that. Mars was manifestly smaller than Jupiter. But as an approximation, it's not a bad one to make. Mercury really is one of the smallest planets. Jupiter really is the biggest. Saturn, they weren't quite sure how big it was because of these mysterious appendages that they'd just started to see. So it's possible that Saturn might have been bigger than it first appeared. If he'd taken the opposite assumption, which he probably knew to be wrong, that all the planets were the same size, he'd do the calculations from that. He would have come up with an astronomical unit of around about 90 million miles, because as it turns out, Venus is pretty much the same size as the Earth. So he knew it was just an approximation, but he came up with an answer that was 10 times better than anybody else had come up with before. They thought it was maybe some single figures of 6 to 10 million miles, as opposed to 60 to 90 million miles for the astronomical unit. So Jeremiah Horrocks expanded the solar system by a factor of 10 just by that one observation. Most importantly, the thing he does say in Venus in Solar, that the reason he'd seen Venus on the sun was as a result of careful calculations. He'd seen it because he did the observations, he did the fitting of the orbit of Venus. He was the guy who realized there was going to be a transit. In particular, Philip Landsberg didn't, and he actually calls him a pompous Belgian in Venus in Solar Visa. I think there's some respect there, but not much. And so he's written this very. I've read it a couple of times. I wouldn't say I was an expert on it by any means, or the very Wilbur Green-Brown or something like that wrote a translation of it, and there are 2 or 3 more around. But it is a careful piece of work in Latin of what actually happened. This is part of this. Cambridge University Library has 3 contemporary copies, and you can see they're handwritten. That's probably not Jeremiah Horrocks' own handwriting, though it might be. It's probably a copy made by somebody from another copy of it. So that's the way that many books were passed around at that time. They sort of hard copies. John Flamsteed, the first Astronomer Royal, had his own copy of Venus in Solar Visa. And if you see up there, about a third of the way from the top, Alice Horace Admirer Avocabar. I was was called away to greater things, and Maiora to greater things, and Avocabar called away. And then about 3/4 of the way down, you get to Gratissimum. It's across the one line, Gratissimum Spectaculum, 6 lines up from the bottom. A most agreeable spectacle. I love that. I said it myself when I saw the transit of Venus. A most agreeable spectacle. So he's written this Venus in Solvesa, which was said to essentially his masterwork. This was his one of his big discoveries, but the biggest. The observation of the transit of Venus through his own observations. And he invites William Crabtree to come across to Toxteth. They've never met before. They've corresponded. Come across and meet him. He also says he's not been feeling too well, but the meeting never happened because Jeremiah Horrocks died on January the 3rd, 1641. So he'd be something like 23 years of age, maybe 22. Crabtree was distraught. I've lost, alas, my dear Horrocks, hinc illae lacrimae, so tears fall, irreparable loss. Crabtree was about the same age as Horrocks. Didn't last too much longer. William Crabtree died in 1644. William Gascoigne, do we say that? No, I'll come to that in a moment. William Gascoigne, the other in the Great Triumvirate, died in 1645, Battle of Marston Moor. Horrocks and Crabtree died through illness. So if the plague doesn't get you, the Roundheads will. It's, you know, life could be short. People did live to for 80 years and 10, but many of them didn't. Jeremiah Horrocks definitely didn't. Made it into his 20s, not much beyond that. Jeremiah Horrocks is, and this is again fascinating story. They were almost lost. Jonas Horrocks took some of his papers and took them to Ireland, where many people disappeared into the various wars in Ireland with Cromwell and so on. Those papers were lost. Some of the others were rescued by John Wallis and John Worthington, his friends from Emmanuel, and Christopher Townley, Jeremiah Shackley, fellow Lancastrian astronomers. So there were people there who realized the value of Jeremiah Horrocks' work, and they weren't published for another 20 years or so. In fact, Hevelius in Poland was the first person to publish them when he observed the transit of Mercury and appended Jeremiah Horrocks' account to his own observations of the transit of Mercury. So, sort of, I'm beginning to round things up, but I wanted to some general themes from this is to what extent there was an astronomical circle, a birth of English astronomy. Well, you can make quite a few claims for it, but I'm going to say that from the north of England, Jeremiah Horrocks of Toxteth, William Crabtree from Salford, observational astronomy, William Gascoigne from Leeds, inventor of the micrometer. Jeremiah Shackley from Burnley, he travelled to India to see the Mercury in transit across the sun, so he saw a transit of Mercury. Christopher Townley, an antiquarian from Burnley, who rescued Horrocks' papers, and John Worthington, his old friend from Emmanuel, a don and cleric from Manchester. So this intellectual circle running across the north of England that valued and preserved Jeremiah Horrocks' worth. Of course, there were others, the Gresham College down in London, Cambridge and Oxford and so on. But you have to say, observationally, these people were extraordinary. These people, Jeremiah Horrocks finding the transit of Venus, William Gascoigne inventing the micrometer. These were cutting-edge, world-class astronomy being done from the north of England, from the rural north of England, not the cities. Well, Manchester. So Horrocks' legacy. Well, Isaac Newton, author of a comprehensive theory of gravitation, he leaned quite heavily. We saw already that he talked about Horrocks in Principia Mathematica. He built on the work of fellow Englishmen from the 17th century, mathematically on John Wallis, astronomically on the work that Jeremiah Horrocks had done. And Horrocks is Newton's friend, Edmund Halley, who realized Halley was not just the comet, a very good astronomer. And one of the things he realized is if you took accurate measurements of transits, the beginning and the end of the transits from different places on the Earth's surface, you could use them to size the solar system. So when we get to the next pair of transits in 1700, people like Captain Cook, Joseph Banks and so on, traveled, Mason Dixon, I go talk about them, traveled around the world to see transits of Venus and time them accurately from various locations to make a more accurate size for the solar system. And that was all based on the original observations of Jeremiah Horrocks. And you can see that the transit in 2004, we were just ideally placed for it. We saw the entire transit. It began, you remember, just after dawn. I was up very early projecting it. I sort of, as that thrill, that wonderful moment as Venus first appeared on the sun, I imagined Jeremiah Horrocks looking over my shoulder, and he said, "A most agreeable spectacle." And I agreed with him. It was just, it's not thrilling, it's just deeply satisfying that you could see it that day. There were other things going on. The weekend before, I joined a residential course at the University of Central Lancashire. Their Institute of Astronomy is the Jeremiah Horrocks Institute, and they put on a course. They had the International Astronomical Union the same weekend, so they had a lot of good people around, and they had a residential course for amateur astronomers, which I joined. And there we are outside Carr House, and we went from Carr House to St Michael's Church, where it would almost move me to tears. The beauty, the flower festival they put on to commemorate the transit of Venus, all over that beautiful hanging basket full of yellow with a single black rose in it. Just gorgeous. And if you look in it, all the flower displays had astronomical themes to them. There was the moon, you could see Jupiter and Saturn and so on. And it was gorgeous, absolutely beautiful in there. They recognize Jeremiah Horrocks. They're proud of him. And they only have to worry about it for a few years, every 100 years or so, as the transits are coming around. And then on the transit day itself, there's the stained glass windows. You can see Ecce Spectaculum Gratissimum Horrocks looking at the transit of Venus. And then on transit day itself, after I'd observed from my back garden, I got in my car and I drove to Cambridge and joined the celebrations at Emmanuel College. I'd written to them the previous year to say, "What are you doing about the transit of Venus?" because I'm interested in him and I'd like to, offer my services to lecture about him. And at Cambridge, they're very good at saying "go away" very, very politely, and that's what they did. They said, "Oh, we don't believe this. Thank you for your interest. Go away," very politely. And then a professor from America wrote to them saying, "I'm coming to observe the transit of Venus from Cambridge. He's an ex-Emmanuel man. What are you doing about it?" And they realised they had to put something on, and they remembered the crazy guy from Rugby, from Lancashire originally, who'd written about the transit, and invited me and the one or two other people along, and we had a fantastic day. Observed from the Institute of Astronomy, which was absolutely packed with people. And Martin Rees, the Astronomer Royal, was wandering around looking very, very pleased with himself, as well he should. Public outreach at its best. Telescopes everywhere projecting the sun and people seeing this. And it was a beautiful sunny day. When do you get that for an astronomical event? Certainly not 1999 for the eclipse of the sun. But we had a perfectly sunny day and the transit of Venus was visible to all. And they had really big cameras on it, so you could observe from inside the hall. And they were watching for that black drop effect, which I haven't said very much about, caused probably by bad optics and air currents and so on, which appears to connect the side of Venus to the edge of the sun, so you can't time it very accurately, and you couldn't really see it from the Institute of Astronomy. But however, and then when the transit was over, we went back to Emmanuel and we had a very good lunch, and as they do at Emmanuel, they're pretty good culinary wise. And then we had a series of talks in the afternoon about astronomical topics, and I was one of the lecturers, and essentially this was the lecture that I delivered on transit day back in 2004. And somebody else in the audience was this chap, Peter Orton, who'd written a very good biography of Jeremiah Horrocks, the brief, brilliant life of Jeremiah Horrocks, father of British astronomy. And then, just in case you don't get it, the transit of Venus in big letters. This is my copy of it here, signed by the author on transit day. It really is very readable. I'd take it's popular astronomy. He does push the facts about as far as they can possibly go. He writes accounts of what they did on various days that you just can't be absolutely certain from the historical record. But he's letting the known facts tell the story. And as a popular astronomy book, I really, really, really like it. There are a couple of things in it I disagree, but actually they're good as well, because when you see something that's not quite right, you start looking at it, and it's like unraveling a carpet. That what starts as just a, why does it say that, when it's actually that, leads you to some fairly interesting discoveries. So I do recommend it if you want to know more about Jeremiah Horrocks. It's really readable book to read, and he's a very good author, like me, an engineer who's turned to astronomical history. So I think that is it. I would encourage you. There's lots about Jeremiah Horrocks, the biography and so on. I'm really pleased that the Transit of Venus came along and gave me the opportunity to tell the story of my fellow Emmanuel Mann, my fellow Lancastrian, my fellow chap who had a cousin who, or thereabouts, who was in Rhode Island. Lots of connections that I have. I'm the right person to tell you about Jeremiah Horrocks. But all in all, I mean, we don't have another chance. We'll probably all be dead when the next transit comes along. That wonderful day back in June 2004, when we saw that most agreeable spectacle of that perfectly circular black disk of Venus in Sole Visa, Venus on the sun. Thank you very much.